In this episode, we're going to take a concept that sounds simple on the surface and show why it becomes tricky in real systems: data minimization. Most beginners hear the phrase and assume it just means collect less data, but the real challenge is collecting and keeping only what you truly need while still delivering a product that works, feels useful, and can be operated reliably day after day. When teams minimize data poorly, they either keep too much and create privacy risk, or they cut too aggressively and break customer experiences, reporting, support, security monitoring, or legal obligations. Data minimization is best understood as a discipline of intentionality, where every field, log entry, and retention decision has a reason that can be explained clearly. The goal is not to starve the business of information, but to remove unnecessary exposure and make the remaining data easier to protect and govern. By the end, you should be able to describe what minimization means across the data lifecycle and how to do it in a way that preserves value. A clear definition helps set the foundation. Data minimization means limiting personal information to what is adequate, relevant, and necessary for a specific purpose. Adequate means you have enough to accomplish the task. Relevant means it actually contributes to the purpose. And necessary means you cannot reasonably achieve the purpose without it. This idea applies to collection, storage, use, sharing, and even how data appears in outputs and logs. It also applies to how precise the data is, because sometimes the same purpose can be achieved with less granularity, like using a city instead of a full street address. Beginners often focus only on the moment of collection, but minimization is just as much about what happens after collection, such as whether data is copied into analytics systems, kept in backups, or replicated across environments. The reason minimization matters in privacy is straightforward. Fewer sensitive data points mean fewer ways people can be harmed if something goes wrong. Just as importantly, minimization makes security and compliance easier because there is less surface area to manage and fewer exceptions to explain. A practical way to execute minimization without breaking product value is to start with purpose statements that are specific enough to guide decisions. A vague purpose like improve the service can justify almost anything, while a concrete purpose like detect account takeover attempts or deliver order status notifications creates boundaries you can work with. Once purposes are clear, you can map each purpose to the minimum data elements required to achieve it, which forces a useful question: what data is truly needed versus what is merely nice to have? This is where teams often discover they have been collecting data because it might be useful someday, which is not the same as being necessary now. A beginner can think of this like packing for a trip. Bringing everything you own feels safe, but it creates extra work, extra risk, and extra clutter. The more disciplined approach is to pack what you need for the planned activities and have a plan for acquiring something later if an unexpected situation arises. Minimization in systems works the same way, with careful planning and clear decision points. A major misconception is that data minimization is always in conflict with good security, because security teams often want detailed logs and identifiers to investigate incidents. The better way to frame it is that minimization and security can support each other when done thoughtfully. For example, security monitoring often needs event patterns, timestamps, device characteristics, and account identifiers, but it may not need full content of messages, full payment details, or full location histories. You can also reduce sensitivity by using pseudonymous identifiers for monitoring rather than direct identifiers, while still enabling investigations through controlled relinking when justified. Another approach is tiered detail, where routine monitoring uses less sensitive summaries, and more detailed information is accessible only under strict controls during a real incident. This keeps operations effective while limiting everyday exposure. Minimization should therefore be treated as precision, not deprivation, with the goal of supporting both privacy and operational resilience. Data minimization also applies to product design choices that are easy to overlook, such as optional fields, default settings, and the way screens encourage users to provide more than needed. If a sign-up form asks for a phone number, address, and birth date by default, many users will provide them even if the product only needs an email and a password. When teams later decide they want to minimize, they discover those extra fields have already been collected and woven into downstream processes. A beginner-friendly insight is that user interfaces shape data collection as much as policies do, because people tend to follow the path the product presents. Good minimization practice includes designing forms to request only required fields by default, making extra fields truly optional and clearly tied to a benefit, and avoiding dark patterns that pressure disclosure. It also includes reviewing whether existing fields still serve a purpose, because products evolve and what was once needed may no longer be necessary. When data collection is intentional, privacy risk is lower and the product experience can actually improve because users see fewer intrusive requests. Granularity is one of the most powerful minimization tools because it lets you keep useful information while reducing sensitivity. Instead of collecting exact dates of birth, a product might collect an age band to support age-appropriate features. Instead of collecting a full home address, a product might collect a postal code to estimate shipping cost or regional availability. Instead of storing exact GPS points, a product might store a course location region to provide local content without tracking precise movement. The key is to match granularity to purpose, which requires asking what decision will be made with the data and what precision that decision truly needs. Beginners sometimes think of minimization as binary. Either you collect a data type or you do not. But in practice, the most meaningful reductions often come from lowering precision. Lower precision can also reduce the chance of unexpected secondary use, because fine-grained data is easier to repurpose for surveillance or profiling. When the data is less specific, it is harder to misuse and often still supports the intended function. Minimization without breaking operations requires paying attention to data flows, because operations often depend on copies that people forget exist. A product may collect personal information in an application database, then replicate it to a reporting database, export it to customer support tools, send it to analytics, and archive it for disaster recovery. If you only minimize the original collection but leave the copies untouched, you have not really reduced risk. This is why data mapping is so important in privacy work, even for beginners. You want to know where data travels, who touches it, and how long it lives in each place. Once you understand the flow, you can apply minimization at multiple points, such as filtering fields before sending data to analytics, using tokenization when passing data to support workflows, or excluding sensitive fields from routine exports. You can also limit who can access the most sensitive copies, and you can reduce the number of environments where sensitive data exists. Operational stability improves when data is less scattered because troubleshooting becomes more consistent and ownership becomes clearer. Retention is another dimension of minimization, because keeping data longer than needed increases exposure without improving value. Teams often keep data indefinitely because storage feels cheap and deletion feels risky, but indefinite retention creates a larger target and a heavier governance burden. The more responsible approach is to set retention periods that match real needs, such as keeping transaction records for a required period, keeping support tickets for a reasonable window, and deleting or de-identifying old logs after their investigative usefulness fades. A key concept for beginners is that retention should be purpose-based, meaning the retention clock is tied to why the data exists, not to convenience. If the purpose is to complete a delivery, the data may not be needed after the delivery is confirmed and any return period ends. If the purpose is to secure accounts, some logs may be needed for trend analysis, but not forever and not at full detail. When retention is designed thoughtfully, minimization becomes ongoing rather than a one-time cleanup. Executing minimization also requires handling the tension between flexibility and necessity, because product teams like data that helps them experiment, measure, and iterate. The privacy-safe version of this is to design measurement around metrics that do not require identifying individuals whenever possible. For example, you can measure feature adoption using aggregated counts rather than storing detailed histories tied to a person. You can also separate experimentation identifiers from real-world identities, so you can analyze patterns without constantly pulling in direct personal information. Another technique is to use sampling, where you collect detailed data for a small, controlled subset under clear rules rather than collecting detailed data about everyone by default. This supports learning while limiting exposure. The important point is that minimizing data does not mean you stop learning. It means you learn with more discipline and with respect for the boundary between what is useful and what is intrusive. A common operational fear is that minimization will make customer support harder because support teams often want full visibility into user details to resolve issues quickly. The better approach is to design support views that show what is necessary for the support task while masking or omitting sensitive fields. If a support agent needs to confirm an account, they might need an account identifier and recent activity summaries, but they may not need full payment details or full address history. You can also create escalation paths where more sensitive access is available only when justified and logged, rather than being open to everyone all the time. This improves privacy and can also reduce fraud risk because fewer people have access to high-value information. Beginners should understand that minimization often requires redesigning workflows, not just deleting fields, because people rely on what they can see. When workflows are designed around necessary information, support can remain effective without becoming a privacy hazard. Another place minimization goes wrong is in logs, debugging data, and error reporting, because these systems often capture whatever is available without careful filtering. A system might record full request details, including personal information, when an error occurs, and those logs may be stored widely and retained for a long time. This is especially risky because logs are often accessible to engineers, operations staff, and sometimes third parties, and they may not be treated with the same sensitivity as primary databases. Minimization here means designing logging to capture what is needed to diagnose issues while avoiding unnecessary personal details, and it means applying retention limits and access controls to logs just like any other sensitive dataset. If a team needs occasional deeper diagnostic detail that can be handled through controlled, time-limited debugging mechanisms rather than permanent, always-on capture. This is a strong example of how minimization supports operations, because cleaner logs reduce noise and make troubleshooting more efficient. Privacy intent is preserved when operational data does not accidentally become a shadow database of personal information. To make minimization defensible, it helps to treat it as a repeatable decision process rather than a one-time promise. That process includes identifying purposes, identifying required data elements, selecting the least sensitive form that supports the purpose, limiting access, limiting retention, and verifying that the system behaves as intended over time. Verification matters because systems drift, teams add fields, and integrations expand, and minimization can quietly erode. It also matters because you want to be able to explain, clearly and confidently, why you collect each category of data and how long you keep it. Beginners sometimes think privacy is mostly about policies, but in practice it is about building habits that keep systems aligned with those policies. When minimization is built into normal product and operational decision-making, it becomes less disruptive and more like good engineering hygiene. Over time, teams that minimize will often move faster because they spend less time handling data risk, less time responding to issues caused by overcollection, and less time untangling complex data inventories. As we wrap up, the main idea to hold on to is that data minimization is not a slogan about collecting less, but a careful way of aligning data practices with real needs so privacy risk is reduced without sacrificing product value. When you define purposes clearly, choose only the data that supports those purposes, reduce granularity when possible, control copying, set reasonable retention, and design support and security workflows around necessary information, you can keep systems useful and trustworthy at the same time. The biggest failures come from treating minimization as an afterthought, because once data spreads across warehouses, logs, and tools, it becomes harder to contain. The most successful approach is to treat minimization as part of everyday engineering and operations, where each new data element must earn its place and each dataset must have a life cycle. When you can explain how minimization supports both privacy and operational reliability, you are thinking the way the CPSC expects, protecting people by designing systems that do not collect or keep what they cannot justify.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.